Marine biologists call coral reefs the rainforests of the oceans. No surprise, really, because these biologically rich ecosystems are home to a quarter of all marine life and are a source of income and food for billions of people worldwide. But they're in danger of being wiped off the map. The Washington-based environmental think tank World Resources Institute has published a major survey tracing the decline of coral reefs. It blames local activities like overfishing, coastal development, and agricultural runoff. But the report also warns of global threats like rising carbon dioxide emissions. This greenhouse gas heats up the planet, making oceans warmer, and it also makes seawater more acidic. Both are bad news for coral reefs. So when our correspondent Josh Zepps told us he was heading to his homeland of Australia, well, we gave him an assignment to look at what's happening to the Earth's largest reef system, the Great Barrier Reef.
It's become a bit of a cliche to say that we live in a globalized world on an interconnected planet. That can be a bit of an exaggeration. Borders do exist, oceans are wide. But when it comes to emissions, when it comes to the atmosphere, to the air that sustains life on this planet, it's no exaggeration to say that what we do right here has a direct impact on what happens here.
If we continue on our way, we will soon see sea temperatures that are 3 to 6 degrees warmer than they are today, and ocean acidities where we know coral reefs can't sustain themselves.
That's Professor Ove Hugh Goldberg, a climate scientist whose warnings made the front page of the Cairns Post newspaper in Australia the day we spoke. To meet him, I headed from New York to a climate change conference in Queensland, Australia, home of the Great Barrier Reef, armed only with my scuba license, a gallon of sunblock, and a guilty conscience for the thousands of pounds of carbon dioxide such a plane ride adds to the problem the professor has been studying.
By the end of the century, we will not have coral reefs with us on this planet.
Including the Great Barrier Reef. It's 1,600 miles long and has around 900 islands. It covers an area more than twice the size of Florida. And according to the World Resources Institute, WRI, if we don't reduce the rate at which we burn fossil fuels and pollute the atmosphere, then within 40 years, nearly all of the world's reefs will be threatened. If you want to understand how inescapable the effects of climate change are on marine ecosystems, this is the place to start. Heron Island is one of the only islands that is literally on the reef. It's made of coral itself, and on it is a reef research station. Marine biologist Pim Bongertz showed me firsthand what's happening.
So this is a coral colony that's basically given up. So it's had a long summer and it's been too hot, and normally in this spot it would have survived even though the tide gets really low and it gets completely exposed. But this one is basically given in. And well, if you could compare that to a piece that's growing right next to it, but it's slightly deeper, you can clearly see the difference in color, where this colony is still healthy.
But the problem isn't just the hot temperatures.
We're putting CO2 into the atmosphere, and so more is going into the ocean. And CO2, when it goes into the ocean, likes to react with water and create an acid.
To grasp what happens when oceans get acidic, let's head back to chemistry class. You drop the coral into an acid environment, and you can see bubbles beginning to form on it. Those are bubbles of CO2 that are caused when the calcium carbonate that the coral is made of dissolves. Now, if that happens out there on a widespread scale, no more reef. To understand how quickly that's happening, Heron Island researchers have built a unique on-site reef climate change experiment.
So these are 12 different mini reefs where we're basically simulating the environmental conditions as they're predicted for the next 50 to 100 years. And so we've got 4 different treatments. One treatment is pretty much the same as it is at the moment. One simulates a pre-industrial conditions, and then the other 2 are conditions that we're predicting that are going to be the result of climate change.
And changes are already happening everywhere.
For example, in 1998, in some places like the Western Indian Ocean, 46% of corals died. Now, the terrestrial equivalent of this is as if 50% of the trees in North America died in 1 year.
Rick McPherson of America's non-profit Coral Reef Alliance says coral reefs aren't just pretty tourist attractions.
We estimate there may be as many as 1 million species yet undiscovered on coral reefs. There are species that are found on reefs that may have chemicals that might be treatments or cures to things like cancer or HIV or any of a variety of other illnesses. So losing our reefs it's not hyperbole to say that we may be losing our medicine cabinet for the world.
Under the sea, the picture I saw was mixed. There was damaged coral as well as healthy, vibrant coral. It was still a beautiful sight to see.
One of the other cool things about tropical islands, of course, is that it's not just the marine life, it's also the plant life on the island itself. Like these halophytes, these saltwater plants, these kind of mangrovey things are also very fragile. Small changes in temperature can affect them, can affect the bird life. Change the marine ecosystem, you change the land ecosystem.
So what can we do? Well, WRI says the good news is the world's coral reefs are resilient and can recuperate after even severe damage. It recommends that we manage climate change locally, support efforts to combat global climate change, and work to reduce our carbon footprint. And if we do that enough, the reefs can survive.
We could either be proactive and take the steps now to save coral reefs, and it is still within our capacity to do this. The window of opportunity has not closed. It's narrow, but it has not closed.
As Josh said, the Great Barrier Reef is a unique ecosystem, but what we see today is only about 6,000 to 8,000 years old. Scientists say the first coral started growing on the edge of Australia's continental shelf about 500,000 years ago, and what's currently visible lies on top of calcified colonies hundreds of feet thick.